So we're here at our last set of vocab, and it's pretty extensive, to be honest, okay? So some of these you may have heard of before. Most of them probably not. So I'm just going to jump right in. Now, for the first four, they all start and sound very similar, okay? So let's start with the addition property. And this is going to start off with if A equals B and C equals D. Okay, so if A equals B and C equals D, then what the addition property says that we can do is we can keep A equal to B, but I'm going to spread them apart a little bit. So I'm going to do A equals B, but leave some space. But what the addition property says is I can take this C and add it to the A, and I can take this D and add it to the B, and the equality will remain true. So this is going to become A plus C is equal to B plus D. Okay, now that's the first version of the addition property. Okay, the second version, so write or in between there, it starts off with, again, if A equals B, only this time I'm just going to add C to both sides. All right, so I'm going to do then A plus C equals B plus C, and then the equality will remain true. Okay, so you've actually done an example like this in algebra before. All right, so I'm going to give you two examples here. So let's say that you have an equation like x minus 2 is equal to 10, right? How would you solve that equation? Well, you'd add 2 to both sides, and you would get x is equal to 12, right? That's the addition property, because what we're doing is we're adding the same thing to both sides, okay? Now, let me compare that and give you an example of what it would look like in geometry, okay? So let's say I have the segment AB is equal to BC, and let's do MN equals NP. What the addition property says is, once again, I can keep this equality between AB and BC. So I'm going to do AB equals BC, but I'm going to add the MN to the AB, and then I'm going to add the NP to the BC. So it's going to be plus MN equals BC plus NP. So that's like a geometry version of it, okay? Now, it's going to be very similar for all of these, okay? So what I'm going to do, though, is for subtraction, multiplication, and division, I'm going to keep this second set here, all right? And that's how I'm going to describe it. So I'm going to do if A equals B, then A minus C is equal to B minus C. Okay, the example of that, and we're not going to do an example for all of them, okay, but let's say I have something like this, okay, let's say I have x plus 2 is equal to y plus 2. Couldn't I subtract 2 on both sides, and I would get x is equal to y? That's an example, all right, of the subtraction property where I'm subtracting 2 from both sides. Now, for multiplication property, it's the same idea, all right? I'm going to do if A equals B, then A times C is equal to B times C. And I'm not going to show an example for that because it's the same idea. The division property, one more time, is if A equals B, then A divided by C is equal to B divided by C. Okay, so those are the first four, all right? Those are all about the operations that we could possibly do and approve, okay? The next three, I think are kind of, I don't know if you guys have seen these before, okay? But what the reflexive property is saying, if you kind of look closer into that word reflexive, I think of the word reflect, right? And if you look into a mirror, what do you see? Well, you see yourself, okay? So what the reflexive property says is for any real number A, okay, so A is going to be just that generic number. then A equals A. So all it's saying is that a number has to equal itself. And we will use this, and you'll see this further on down the line of when this would be applicable, all right, in a proof. Now, the symmetric property, I think of the word symmetry, right? So what this one is saying is if A equals B, then B equals A. So you actually use this a lot, and you probably just haven't realized it, okay? But like an example of this is, let's say you're solving an equation, right? And what you get is 7 is equal to X. Now, I don't like having the 7 on the left-hand side. I like to have my X on that other side. So what it's saying is that you can just flip-flop them into X equals 7, and the equality remains true. All right, so when you just flip those signs, all right, then the equality remains true. Now, the transitive property says if A equals B and B equals C, then A equals C. So let me give you like a real world example, or not a real world, sorry, a geometric example. So let's say that the length of AB is equal to the length of BC. But then you also have BC is equal to ED. What's our conclusion? Well, then we can get rid of those BCs and just say AB is equal to ED. Okay, so for the last two, the substitution property says is if A equals B, then you can replace any expression B with A. Okay, so for example, you guys use this, all right? So let's say you have the expression 7x plus 5, but then you're also given x is equal to 10, all right? Can't you take this 10 and substitute it in for that x? You can, right? So I can have 7 times 10 plus 5, and that step right there is the substitution step. You can then simplify, but that step of substituting it in, all right, is that substitution step. Now, my last one here is the distributive property. You guys have done this before, but it's just saying that if you have this number on the outside of parentheses and you have B plus C inside those parentheses, we can take this A and distribute it through, and we would get AB plus AC, right? So an example of that is if you had 2 times x plus 4, when you distribute that 2 through, you'd get 2x plus 8. All right, I'm going to pause there and then go ahead and do the identify the following properties, and then we'll be done.